Okay, here is practice 9F. These should be solved identical to the ones on 9E, and I'm going to label each one of these as the known, what we're starting with. That will be yellow, and the unknown is blue. So here is number 1. Our known is clearly 185 grams of Cl2. That's where we're starting from. And what the question is asking us to find is how many grams of NaCl. So here is our unknown. All right, we're going to set it up just like we did practice 9E. We're going to ask how many grams of our unknown NaCl is the equivalent to 185 grams of our known, which in this case is Cl2. So I'm looking on the periodic table, and the molar mass of Cl2 is 36 grams. So I'm going to multiply that by 2. Therefore, our molar mass of Cl2 is 72 grams. We have a balanced equation, and so we're going from moles of our known to moles of our unknown. And we see coefficients. Well, we only see one. There's no coefficient by the chlorine, which means that coefficient is 1. And the last one that we're going to do is going from moles of our unknown to grams of our unknown. And we know the molar mass is 59 grams. So we're going to say 185 divided by 72 times 2 times 59. We get 303 grams of NaCl. So be sure that you are labeling everything. How many grams of our unknown is the equivalent to the mass of our known. All these things are known, and then of course solving for the unknown looks like that. Okay? Here we go, number 2. Lithium metal reacts with nitrogen gas to produce lithium nitride. According to this reaction, it is asking how many grams of lithium nitride could we expect from the reaction of 75 grams of lithium. So it's asking for how many grams of lithium nitride would be the equivalent of 75 grams of lithium. Alright, so the first thing that we're going to do is find the molar mass of lithium on your periodic table. It is 7 grams in 1 mole. Now we can go from moles of lithium to moles of what we're looking for, Li3N. According to the equation, the ratio is 2 for the lithium nitride and 6 for the lithium. And now we can go from moles of lithium nitride to grams. And we know that nitrogen has a mass of 14 grams. There are 3 lithiums in there, each 7. So 3 times 7 is 21 plus 14, and we have a molar mass of 35 grams. All right, so notice that we have started by identifying our known, getting from grams of our known to moles of our known. Now we can convert from moles of our known to moles of our unknown and then find the mass. So I'm going to say 75 grams times 1 divided by 7 times 2 divided by 6 times 35. And this is 125 grams of lithium nitride. All right. Halfway done. We've only taken 4 minutes, so we're doing pretty good. This one's pretty big, but I've given you the balanced equation, and it says a reaction takes place between aqueous copper 2 sulfate and iron to produce iron 3 sulfate and copper. And it's asking how many grams of copper 2 sulfate, that's our unknown, could be required to react with 0.017 grams of iron. So we're going to ask how many grams of copper 2 sulfate. And if you're wondering which one that is, that's this guy. So we're going to ask how many grams of copper 2 sulfate are the equivalent of 0.017 grams of iron, which is, of course, that dude right there. So we're going to go from grams of iron to moles of iron. We know that 1 mole of iron is 56 grams. That comes right from your periodic table. Now we can go from moles of iron to moles of copper to sulfate. And what's nice is that we have a balanced equation, so we don't have to look for coefficients. They're already provided. And now we can go from moles of copper to sulfate to grams of copper to sulfate. We know that there are 4 oxygens in there, each 16, so that's 64. The sulfur is contributing 32, and the copper is also 64. So we have 64 plus 64 is 128 plus 32, and this is a molar mass of 160. So what I'm going to do is I'm going to go and say, all right, we know this is our known. We're going to go from mass of our known to moles of our known, from moles of our known to moles of our unknown, and from moles of our unknown to mass. So we'll say 0.017 times 1 divided by 56 times 3 divided by 2 times 160. This is 0.073 grams of copper to sulfate. Okay, that took us 6.5 minutes, so we're already on the last one. We're flying. Here we go. How many grams of CO2 with a combustion of 1,500 grams? That's supposed to say of, not on. Typo. 15 grams of heptane produce, and so a heptane looks like that. The CO2 is our unknown, and that looks like this. We're going to ask how many grams of CO2 could we get from 1,500 grams of heptane, which is clearly C7H14. So, I'm going to go from grams of heptane, C7H14, to moles of heptane. What we know is that each carbon is 12 grams and there are 7 of them. Each hydrogen is 1 gram and there are 14 of them. So we're going to say 7 times 12, which is 84, plus 14 is 98 grams. Now we can go from moles of heptane, C7H14, to moles of CO2, and the equation is already balanced. We know that the ratio is 14 to 2. And now we can go from moles of CO2 to grams of CO2. And we know that 1 mole of CO2 is 44 grams, carbon is 12, and there's 1 of them. There are 2 oxygens, and they're each 16, which is 32, plus 12 is 44. So we're going to say 1,500 divided by 98 times 14 divided by 2 times 44. Keep in mind that what we're doing here is going from grams of our known to moles of our known, from moles of our known to moles of our unknown, and then from moles of our unknown to mass, which is what the question is asking for. So we're going to say 1,500 divided by 98 times 14 divided by 2 times 44, and we get 4,714.3 grams of CO2. That's all we do. All right. You're all done. Took us 9 minutes. Good luck on the quiz tomorrow.